Welcome to this short recorded video that is the second video in the prologue lecture for Computational Applications Module 4 of Math 1376. We will go over subclasses and superclasses in this video. I like the following tutorial for an overview of subclasses and superclasses because it is not overly technical in its presentation. I've worked through and expand upon part of that example from that the example from that tutorial below, but you can click on here for more information. For a simple use case example that is kind of silly and easy to read, you may also want to check out this blog that I linked to here. Let's imagine that you have a class polygon used as a template for all polygonal objects. It might look something like what we have below. And by the way, now, unlike the silly example I was showing before, I'm using more of the convention of that you use in Python for class naming, where you can have many words put together and you just capitalize the first letter of each word. That's generally a convention for naming classes, but sometimes it doesn't work. It's just a convention, and sometimes you have to break the convention. For instance, in the silly example I was showing in the first video, it would have been very awkward for me to follow that naming convention by putting I am what I am no matter what you say as one long string of characters where it was capital I, capital A with no underscore in between, and then a capital W with no underscore between the A and M. You can imagine it would have looked ridiculous. So, that was just an illustrative example, but sometimes you can't follow conventions. But in general, it's a good idea to, and short descriptive class names are good, and using 1 to 3 words per class name where you capitalize the first letter of each word and just put them all the words together. That's the general convention. We're not going to dwell on it anymore, but here's our class of polygon. And again, I'm putting object here, and again, that's not necessary. I mentioned that in the first video. Now, for a polygon, what do you need? You need to know the number of sides. So I pass it a variable that I'm assuming is the number of sides, an integer. I'm not checking data types, but I'm assuming it's instantiated with a number of sides, and then I create the data attribute self.num underscore sides based on however I've initialized it. And then if I ask it, what am I? That's the method attribute. I create a string that is I am a polygon with, and then I turn that, hopefully an integer, to a string. I cast it as a string, a polygon with however many number of sides it has, and I print that information. Now, rectangles and squares are certainly types of polygons. These are, in fact, special types of four-sided polygons. Moreover, a square is just a special type of a rectangle. In this case, you would start to think of creating perhaps a rectangle as a subclass of a polygon, and a square as a subclass of a rectangle. See below for what we're going to show in these examples, and pay attention to the arguments in these class declarations. The argument in the class declaration here for rectangle is polygon. That's what's defining it as a subclass of polygon, which means it inherits some of the same stuff. Now, from that, I'm calling the superclass, which is the polygon, and its initialization function with number of sides equal to 4. Notice for the rectangle, when I initialize it, I just say, give me two variables, length and width. There's no length and width, there's just number of sides up here. But I know a rectangle has 4 sides. So I call the superclass, that is polygon, which is referencing this, and I say, this is a type of polygon with 4 sides. This rectangle now inherits from polygon. And then I also have self.length and self.width defined by the length and width of the rectangle that was used to initialize the rectangle. So I give 2 numbers that are like floats to initialize this rectangle, and then I use 4 as the integer to initialize the number of sides of the polygon. Now, the nice thing about a rectangle is I know how to compute the area of a rectangle. Well, and that's a method attribute. It only needs to reference itself because it has the data objects length and width. And then self.area, a new data attribute, is computed by multiplying the length and width that are the data attributes for the rectangle that are determined upon initialization. I can ask it for its area by saying, what is basically my area? And it will try to print self.area. If that hasn't been defined yet because compute area has not been called in order to create this data attribute, so that creates an attribute error, well then, in that case, the object will then call compute area, and then it will print self.area. I can also compute the perimeter as 2 times the length and 2 times the width, and store that as a new data attribute, self.perimeter. And I can call my perimeter to get the information about what the perimeter is for the rectangle. And just like with the my area, I can try to print that data attribute. And if that data attribute doesn't exist yet because compute perimeter hasn't been called, then that will produce an attribute error. And in that case, I catch the error, that's the try and accept. And then I call the compute perimeter method within the object itself, just like I did with compute area here. And then I can print that perimeter. The next time I ask for my perimeter, it would just go through this. And then I also have a my dimensions, which will print the length and the width. Notice I do not have what am I, right? I don't have it at all, but I inherit it from the polygon. So let's go ahead and see how this works. That might seem a lot to take in. You might have to rewatch that part of the video once or twice in order to really get some of this to sink in, as well as seeing what follows. So we're going to create a rectangle called A that's going to have length 2 and width 4. And if I ask it, what am I? Again, what am I? That does not show up here. That's here. It inherits from the polygon. Because it's a subclass of polygon, I'm inheriting that, and it will say, I am a polygon with 4 sides. I am a polygon with 4 sides. Now, if I ask it for my area, right, it's going to try to print this, but that will produce an attribute error, and then it will go and do this and compute area and then print that self area. So when I say my area gets 8, 2 times 4 is 8. My perimeter, 2 times 2 is 4, 2 times 4 is 8, 8 plus 4, 12. I'm hoping I did that right. There we go, 12. And if I ask it for my dimensions, length equals 2 and width equals 4. And notice I had a line return there so that it was easy to read. Square is just a type of rectangle. And the nice thing is when I call this, there's nothing else I need to initialize. I just need a length, right? When I talk about a square, I just give one length and it's the length of all sides. So when I call the superclass, which is the rectangle, I initialize it with a length that is length and a width that is length. I don't have to rewrite any of this stuff in Square. So the point of this is this superclass might be sparse. It might not have too many things in it. And then one subclass might have a bunch of new methods and data attributes that are specific to that particular type of subclass that don't belong in the superclass, because not every polygon is a rectangle, and not every polygon then is going to have a compute area or a compute perimeter function that looks like what I've done with this rectangle. But a square is going to have all the same functions as a rectangle, except it only has one effectively dimension to it, which is the length and the width are the same. They're the same value. So I just use the superclass, which is the rectangle. I initialize it with length is length, width is length, and it then calls this rectangle, which itself calls the polygon. And then I can say I overwrite my dimensions, right? If I didn't have this here, I'll do this. I'll comment that out. Imagine that this was it for the square. And then I create the square B, which as a square object with length 2. And if I ask it for my area, it'll be 4, because 2 times 2 is 4. My dimensions, length and width, are both 2. If I ask what am I, it's a polygon with 4 sides. But notice when I said my dimensions, saying the length is 2 and the width is 2, it's using the method attribute it inherited from the rectangle. If I come back here and uncomment this out, and I rerun this, you have to rerun it. So now when I instantiate the square class, I've overwritten any inherited method attribute that's called my dimensions with what I have here. So now look, I ran it again. I didn't need to do that. But here's B, here's my area. Now when I ask it for my dimensions, it just says the length is the width is 2. It's formatted differently because it's using this method attribute. So if you have data attributes or method attributes that appear in the superclass and in the subclass, it will always use the subclass. It is assuming that you intended to overwrite those attributes if you use them again with the same names in the subclass. So that's very important. You can then venture into the third dimension. So here I create a new class of objects called cubes. Well, I called cube, a new class of objects that are cubes, and I'll just call it a cube. The face of a cube is a square. We may choose to initialize the face attribute as an object. So here's a class cube that is an object. I'm initializing it with an edge length. So a cube is like a three-dimensional square. The length of every side of the cube is the same edge length. The faces are squares, so I actually call the square object, and then it will have a length that is the edge length. That square will call then the rectangle, and that rectangle will call the polygon. But that means that the faces, I can compute the area of each face. I can, upon initialization, call other methods. I haven't been doing that yet, but we always could. I'm computing the area of the faces here in the initialization. So this is from the faces data attribute, which is itself a class. It's an instantiation of the class, so it's an object. And then self.compute surface area, that's for the cube. A cube has 6 faces. They all have the same area. 6 times that area, and area is the data attribute that I get when I compute the area, right? Because when I compute area, I get the area attribute for the faces. And then I can also compute the volume by taking the faces, the area of each face, and multiplying it by the length of each edge. So these method attributes are called upon initialization. I similarly could have called compute area and compute perimeter upon initialization here. There's nothing stopping me. I just chose not to do it. Sometimes you want your initialization to be lightweight. Maybe I want to create rectangles, and I really never care about the area or the perimeter for a particular application. So I don't want to have wasted computations upon initialization. I just want to initialize them and have the length and width available. That's all I want. Then I don't want to compute the area. Or maybe I say, it's good just to have these upon initialization, in which case I call the methods upon initialization to generate other data attributes like surface area and volume, like I'm doing for the cube. These are design choices. There's not necessarily a right or wrong answer. It's just kind of what you think is best when you're writing the code. And then I ask, what am I? And I am definitely overriding what's inherited. Or actually, this is not inheriting from anything. It's its own object, so it's not inheriting from Polygon. It is a cube with a certain edge length. So let's just look at the C. That is this instantiation of this cube with edge length 2. So notice, compute surface area is a method. It's called upon initialization, and then it creates a data attribute that is surf area, surf underscore area for surface area. And it tells you what that data attribute is. If I ask, what am I? It is a cube with length 2. The faces of the cube are squares. And if I ask those faces what they are, they say they are a polygon with 4 sides. Because remember, the square inherits from the rectangle inherits from the polygon, and the polygon has what am I. So the what am I for the cube is for the cube object, but the cube object has data attributes that are themselves classes that also have a what am I. So you just use the dot convention as usual. C dot faces dot what am I is not the same thing as C dot what am I. This is calling the what am I method that was inherited all the way from the polygon class. Okay. And then C dot volume, because remember upon initialization, we computed the volume, and then that created a data attribute, self dot volume. And there we go. C dot volume is 8. And that brings us to one of the last activities in this, which is to make your own classes and subclasses. Again, I actually won't have a video for this because it's just really about what you want to do to make your own classes and subclasses. I give some ideas, but you can search Google, get creative. This is really about you exploring and doing something on your own. And then the very last part, which is a video I will make next, is about importing and using a module of classes. That'll be the third and last video of this Prolog lecture notebook. Thanks for listening.